Hello friends, welcome to FreeCAD tutorial, and this is the tutorial number 129, and this is the part modeling tutorial. And here you can see that I have converted this orthographic drawing into the 3D model with the help of a FreeCAD part design workbench, and you can see that our FreeCAD model is matching with the isometric view. And this is the little bit complex part, and I will show you from the scratch how you can model this part in FreeCAD. So I will close this file and create a new file, and I will show you from the scratch. You can also visit my website mechnexus.com, where I write articles and tutorials on FreeCAD. You can download my tutorial source file from here, tutorial source file page, and you can also support me by buying a cup of coffee on ko-fi.com. Your small support will help these channels to grow, and it will motivate me to create more awesome content on FreeCAD. I thanks to all my supporter, those who have supported me by buying a cup of coffee. So keep supporting, and it will help me to grow this channel, and it will motivate me to create more awesome and useful tutorials on FreeCAD. So let's come back to our tutorial. So here I have created a new file, and I have inserted the body, and now I will on the origin plane. So if we see our model, so first we will create this base revolve features, and dimension we can get from here. So I will select this front plane and create a sketch. Go to the model tab, and I will off this origin plane, and now I will start the sketching. So first thing which I will do is to start from here. So this is the will be our axis of revolution. So first thing which I will do, I will create a rectangle, and I will delete this horizontal line, and I will move it, and here I will give the dimension. So select the smart dimension, and our thickness is of 5 mm. So let's give the 5 mm thickness here, and now select this point and this axis, and it is a diameter 30, so radius will be the 15, and I will move this dimension. Now I will draw the two horizontal line, one here and one here, and select the dimension, select this and this, and give it 5 mm, and let's fix the total height, which is of 92 mm from the origin. So select smart dimension, select this and origin point, and provide the 92, and now we can see here the 12 mm dimension. So select this line and provide the 12 mm, and we will make it shorter. Now this is the diameter 46, which means that radius will be 23. So I will select dimension, select this axis and this, and provide it 23, and I will move it, and now I will create a line at an angle, and we will make this both parallel. Select dimension and provide the thickness of 5 mm, and now here is a cut. So and here is a detail view is given, which means that this line will come in an angle. So now I will extend this line and select a line tool, draw the horizontal line and then vertical line, and make it vertical. And now I will create a line, select the line tool, and I will select this and make it parallel. Select this and make it construction. And now I will draw the horizontal line, select this point and this line, and add a coincidence. Select the trim option, and now here is a 8 mm, so select the smart dimension and provide this 8 mm, and from this to this is of 3 mm. If we zoom it, we can see these dimensions 3 mm, and from here to this one is of 56. And let's see what is unconstrained. So here is a angle, so we will make this horizontal and make this and this coincidence. So our profile is fully constrained, but here we will create this construction geometry because it will help us to create a datum plane. So I will select a line tool and select this and make it parallel, because here is a 12 mm. So I will select the dimension, select this and provide the 12 mm, and I will make it a construction. And here if you see that center to the bottom is of 56, so I will select the line tool and select this and made it perpendicular, and I will also make it a construction. And now I will select the smart dimension, select this point and this point, and here is a value of 56, enter it. And now the next thing is this line is of 35, because here is a diameter 35. So select the dimension option and define is 35, and this will be the symmetric. So you can see that I can move it. So I will use symmetricity constraint, select this point and this axis, so it is now symmetric. And now I will select a line and create a perpendicular line. Select this point and select this and make it construction. Select this and make it perpendicular, and select line tool, make it construction. Select this and make it perpendicular. And now we will come out of the sketch. We will not revolve it because we will insert a datum plane. So I will make this line visible so that I can see my profile. Now I will on the origin plane, so I will select this bottom plane and create a datum plane at a distance of 56, and I will also create a datum plane. So for this, let's measure the distance. Let's go to the sketch, and from this axis to this point is of 40.88. So I will close it, select this datum plane, and give the offset distance 45.88. So the logic behind removing the construction line to the normal line is that we have exactly created the two planes. Now we will create an axis. Now select this plane and this plane, so you can see that axis has been created. Now I will rebuild it. Now we will create a datum plane. So here click on create a datum plane and select this the axis which we have created, and now here we will select the exit, and in an angle in a y-axis we will provide 67.58. so you can see that it is perfectly with respect to our construction geometry. Now I will rebuild it, and I will go again to the sketch, and now we will make this all geometry as a construction again, because we do not require it as of now. Also make it a construction. Go to the model tab and of this origin plane and also of this datum plane, and come out of the sketch. Now we will select our sketch and create a revolve. Okay, now we will on this datum plane, and here we will create our sketch. Select the datum plane and click on the sketch, switch to the wireframe view, and here I will create a circle, and now I will on the datum plane so that center is a perfect. Now I will give the dimension which is of a 35. So select the dimension tool and give it 35. Now close it off the datum plane and axis, and from here switch to the flat lines. Select the sketch, click on extrude, and from here select up to face. So you can see that this is created, but the thing is here, this is in the taper. If you see here, this is in the taper. So what we will do, we will select this face and create a sketch. Now we will create this draft feature. If you see that, we can see here the draft, and this is the angle of a 15 which you can find from this sketch. So here is our diameter 35 which we can see here, and if we draw the perpendicular line and maintain this angle 33, so we can find that this is the 15-degree angle will come, because this line and this line is parallel to each other. So now we will select the face and click on the sketch, click on the project geometry, and project it and select the circle and make this equal. Now I will close it, and here I will select the sketch and click on pad, and from here I will select the reverse, and draft angle will be the 15, and distance I will increase it so that it open the inside. Let's make it approximate 25 mm, and we will rotate and see that it is opening. Click on OK. And now our next task is to create a profile and remove this unnecessary material with the help of a revolve cut. So I will switch my model to the isometric view and on my origin plane, and select this front plane and click on the sketch. Now I will switch to the wireframe view, and here I will click on the project geometry. I will project this edge and this edge, and I will select the line tool, and here I will off the origin plane, select the line tool, switch to the front, select this and this and join it, and make it horizontal. Select the point and this axis and make it coincidence, and we will close our profile. Now we will come out of the sketch, and from here I will switch to the flat lines and simply select the revolve cut, say OK. Now this is the complete solid, and if we go in a shaded view, that's okay. Now let's switch to the flat lines again, and our next feature is to create a cut here. So we will create this profile. So for this I will again on my origin plane switch to the front view, select the exact plane and click on the sketch, and I will off the origin plane, and from here I will switch to the wireframe, and here the thing I will do is to project the edges. Select this edge and also project this edge. So here we can see that wall thickness is of 5 mm. So I will select the line tool and create a two line and select this and this and add a parallelity. But here, as this is a taper face, so I will create a line by joining these 2 points, and I will make it a construction. To check it, I will come out of the sketch. So this is not construction, so I will simply drag it and make it construction. Let's check it. Yes, now it is construction, because construction line will not be get visible once you come out of the sketch. So here now I will select this and this, and now I can add the parallelity. and I will select the dimension tool and provide the 5 mm, and I will select this and add a parallel and select dimension tool and add a dimension of 5 mm to the front, and I move it. Now I will project this inner edge. Click on the project geometry, project this and this, and here I will create a line and in this line here I will select the line tool and create a line, make it a construction and make this and this, and make it a perpendicular. Select the right view, front view, and now select the dimension tool and make it construction. Now select the dimension option, select this to this, and as it is diameter 35, so it will be 35 divided by 2, and here let's add the relation, but relation is added because it is a perpendicular. And now I will select this point and this line and make it a coincidence, and I will move this dimension. Now this line is not important because we are going to make a cut with respect to this axis, so I will make this dimension approximate. Select this and click on the perpendicularity, select the line tool and close our profile, and select the dimension tool and give it 35. And now let's remove the material. Click on the revolve cut. So here you can see that it does not identify the real axis, so I will give my own reference and I will select this line, click on OK. Now I will switch to the isometric view and I will cross check my model. So I will go to the view and then persistent section cut, and I will select this y axis and I will make it normal. So you can see that this profile is now perfectly matching here. Now the complication is here as well, which we will discuss next. Now I will close it, and here I will off my section view. Now let's move to the next feature, which is to create this slot, which we can see here. So we have made it, and we will select the face and create this slot, which is very simple feature. All I have to do is project this diameter, and if you see here, here is a diameter 20 is given, which means that a PCD is of 20. So I will create a circle, make it a construction and provide it a 20 mm, and now we have the slot option is here. Create a center arc slot, escape it again, let's create a rough slot, and now let's select the center points and add a coincidence. And now we can see that this is the 20 and here is the angle of a 70. So we will create a construction line, select center points and join with this, and select this both line and make it construction. And now angle is of a 70 degree, so we will provide the angle. This to this is of 35, and this to this is of 70. And now I will select this center point and this our PCD diameter and add a coincidence relation, and select the dimension. This to this is of 5 mm. So here is the diameter 5 mm, so I will select the diameter and give it 5 mm. So this is our slot. Let's come out of the sketch and I will edit my sketch. So here this will not be coincident to diameter, but it will be coincident to this PCD. So we will go here and delete the constraint. Now move it. Yes, now select this and this PCD diameter and add a coincidence. Now it is perfect. Yes, now we will select the sketch and click on the cut, and from here I will select up to face and I will define my end condition to this inside face. Now click on OK. Now we will pattern it, which we can see here. So I will select the pocket and click on the circular pattern, and here I define my own reference. So I wanted to pattern around this diameter and provide the quantity 3. Click on OK, and now I will come out of this pattern feature, and our next feature is to make this feature. So for this, first I will set my model to the isometric, and now we can see here the 5 features. So I will select this bottom face and click on the sketch, and here we can see that radius is of R9. So let's make our model to the isometric and set it to the bottom position, and now we can see here the PCD given is of the 100 mm. So I will select the circle, create a circle, select it and make it construction, select diameter, provide it 100 mm, and now for my convenience I will switch to the wireframe, and here I will select a 3-point arc. I will create a rough 3-point arc, and I will select this point and axis. I will make it coincidence, and then I will select it and make it a coincidence with my PCD diameter. Now this is of the R9, so I will go here and give it R9, and here we can see that the tangent line is there, which is the angle of 72. So I will select a line tool, and first I will create very rough line. Now select this and add a tangency, select this and add a tangency. Now it is the angle of 72, so I will select this and provide it 36, and this to this is of 72. And now I will move this and create one more 3-point arc. So I will go here, create a 3-point arc, select this and add a coincidence. And this is the very approximate because I wanted to merge the material, and this I will give the approximate radius by offsetting it, but for time being this is as a construction, so I will select all this and make it construction because we want to add the material, and for time being I will make it equal. Now here is our wall thickness is of 5 mm, which we can see here. So we will create an offset. So I will again select a 3-point arc and select this and add a coincidence and 5 mm thickness, which means that if it is R9 then it will be the R14. Select it and provide it R14, and here is the same. I will create a tangent line, select this and add a tangency, select this and add a tangency, and now I will approximately place it here, and I will select these two and provide the parallelity to maintain the angle, add parallelity, and now I will create a 3-point arc and I will select this and add a coincidence, and this I will give very rough diameter, let's say radius, let's see, give it a 55. Now I will close it and I will switch to the flat lines. Let's first switch to the wireframe and then flat lines. Click on pad, select up to shape, let's see, and make it reverse, and so you can see that it is a up to shape is the option working perfectly. Now we will pattern it at some 5 locations, so we will select the pad and click on the circular pattern. So it automatically took that Z axis, and let's give the quantity 5 equal spacing. Now click on OK. Now we will move to the next feature, which is to create a cut, which we can see here. So we will switch our model to the isometric view, and here we will select this face and click on the sketch, and I will switch to the isometric view and click on the top, and from here I will switch to the wireframe, so we can see the profile here. So now here we have the PCD of the 100. So I will select the circle tool and create a circle and make it construction and define its dimensions 100 mm. And now I will select the 3-point arc as we have did earlier, and select this and this and add a coincidence. Now select this and this and add a coincidence, and this is of R9. But before that I will create a 2 line on the both the sides, this and this here, and here let's see if in a projection we can get a line, but I will prefer to give the tangency and angle. So I will define the tangency, select this and this and define the tangency. Now let's constrain the radius, which is of R9, and here we will project the outer diameter here. So we wanted to remove the material, so instead of making this radius and this 72-degree angle line, we will create a line and we will define it a vertical, and here we will select this and this and provide it 36, and this and this 72, and let's give a rough dimension whatever it may become. Click on close, and now switch to the flat lines. Now we will remove the material, select the sketch, click on the pocket, and here we will reverse it and we will say it through all. So you can see that this cut which we can see in isometric view is created. Click on OK, and now we will pattern it to the 5 locations. Select the pocket, click on the polar pattern, and define the quantity 5. I'm sure it took the Z axis. Yes, it took the Z axis. Click on OK. Now we will create this counter bore holes which we can see in a drawing. So for counter bore holes we will create one hole here and we will pattern it. So we will select the face and click on the sketch, and we will switch to the wireframe and click on the project geometry. So here the projection seems to be weird, so I will delete it. So we have a PCD diameter and we will simply make our hole coincident to this PCD diameter. So I will create a circle. Let's make it construction, select the dimension and provide this 100 mm. Now we will create a circle which will be coincident to this axis and this PCD diameter. So first I will create this on the axis, select this and I will make it coincidence, and here it is of diameter 7. Now I will close it. Now let's switch to the flat lines. Let's shade it and then flat lines. So we can see our whole sketch. So I will select the sketch, click on the hole, and now we will create the contour bore hole. So here is my hole wizard. So my 7 mm diameter is of through. So here I will define the 7 mm diameter and define the end condition through. And now here I will select the contour bore. So my contour bore diameter is of a 15 mm. So I will give the 15, and depth of the hole is of 3 mm. So I will give it 3 mm. Now click on OK. Now we will select the hole tool and click on the polar pattern. It is calculating, and give it 5. So you can see that beautifully 5 contour bore holes has been placed. Now you can see that we have successfully converted this orthographic drawing into the 3D model, and we will give our final touch. We will go to the appearances, and here we will select the diffuse color, and I will select this color, click on close. Now if you wanted to check our cross section, so I will on my section view and off my body. So you can see that this section is matching with our drawing, and this profile is matching with this one. And I will off my sections and on my body. So this is how we have created this model, and our model is perfectly matching with a isometric view. So this was a little bit complicated model, and I'm very happy to see that FreeCAD 1.0 is able to do this type of a complex model. So this is all about this tutorial. Thank you for watching, and thank you for your valuable time.